Hello Algebra 1 students, section 7-2 part 1, factoring by GCF, greatest common factor. Before we start, you have to recall two very important skills. Skill number 1, distributive property. When you have a monomial 2 multiplied by a binomial w plus 1, you need to multiply this 2 times the first term and the second term. So it's 2 times w plus 2 times 1. If you simplify that, it gives you 2w plus 2. Distributive property is the reverse of factoring by the GCF of today. Another skill, find the GCF of each pair of monomials. We given a pair of monomials 4h squared and 6h, and we need to find the GCF of this pair of monomials. Step number 1, we factor both of them completely. We factor the 4 prime factorization 2 times 2, and h squared is h times h. Similarly, 6h is factored 2 times 3 times h. Remember guys, to find the GCF, you need to circle any pair of common factors. I have this 2 and this 2, they are common. This h and this h are also in common, and you take one factor of each repeated or common pair. So you take 2 from this pair and you take h from that pair. So the GCF of these two monomials is 2h. Today our job is to factor polynomials by using the GCF. Example number 1, factor each polynomial, check your answer. How do I factor this polynomial? Guys, to factor this polynomial, you have to be aware that this polynomial is a binomial. It has two terms. To factor this by the GCF, you factor each monomial. So you factor 2x squared. 2 is already factored because it's a prime number, so it's 2. X squared can be written x times x minus, we're gonna keep the same sign. 4 can be factored prime factorization 2 times 2. Now guys, similar to the warm-up question, we circle any common factor, any pair of common factor we find. This 2 is in common. This x not in common, this x not in common. So we take this 2 outside because it's common, and we draw parentheses, and we expect a binomial inside because our original polynomial is a binomial. So we expect two terms. What is the leftover of the first thing? We take this 2 outside, we factor this 2 outside, so the leftover is x times x, it's x squared. We keep the negative sign. We already factored out this 2, and the leftover is 2. How do I check my answer? How do I check my factoring, whether it's correct or not? By doing the inverse of factoring, which is distributive property mentally. 2 times x squared, it gives us 2x squared. 2 times negative 2, it gives us negative 4. So the factoring is perfect. Another example. Negative 14x minus 12x squared. I need to factor that polynomial by GCF. So guys, similarly, we can factor each monomial and circle the common factor, or we can speed up the process and get the GCF directly. The GCF among negative 14 and the negative 12 is negative 2. The negative sign is common, so we take it out, and the GCF of 14 and the 12 is 2. For the variables x and x squared, we take the variable with the least power, so we take x. So the common factor of negative 14x and the negative 12x squared is negative 2x. We factor out this, and we draw parentheses, and we expect a binomial because we started with a binomial. How do we get whatever inside? You ask yourself, negative 14x is equal to negative 2x times what? Times 7. Yes. Negative 12x squared is negative 2x times what? Times 6x. How do I know whether my answer is correct or not? You can do distributive property mentally. Negative 2x times 7, negative 14x. Negative 2x times positive 6x, negative 12x squared. It's perfect. Correct. This time we have a polynomial. Actually, it's a trinomial, and we need to factor this trinomial by the GCF. What is the GCF among the coefficients 8, 4, and 16, regardless the negative sign? Ignore the negative sign. The GCF among 8, 4, and 16 is 4. And the GCF among the variables is the variable with the least power. The variable with the least power is x to the power 1, or simply x. So the GCF of the whole polynomial is 4x. You create parentheses, and this time, guys, you should expect a trinomial inside, because our original polynomial is a trinomial 1, 2, 3 terms. How do I get the answer inside? Either you ask yourself, 8x cubed is 4x times what? Times 2x squared. Or another method, you can simply divide each term of this polynomial by the GCF, by 4x. So 8 divided by 4, it's 2. X cubed divided by x to the 1, you subtract the exponents, so it's x to the power 2. This is another method. Let's continue. Negative, we copy that negative, we don't change the sign. 4x squared divided by 4x, it gives us 1x, or simply x. Negative 16 divided by 4 is 4. X divided by x, they cross out each other. Distribute property mentally very quickly to make sure everything is okay. 4x times 2x squared is 8x cubed. 4x times negative x, it's negative 4x squared. 4x times negative 4, it's negative 16x. It's perfect. Another example. Factor the polynomial using the GCF if possible. Look at this, guys. What is the GCF of the coefficients 3, 2, and 10? What is in common between 3, 2, and 10? Nothing. Yes, nothing. You might say 1. Yes, 1 is a default GCF of any two things or any three terms, but we can't write 1 because we do prime factorization. Exactly. And 1 is not a prime number. So nothing in common between 3, 2, and 10. What about the variables? We have x to the 3, x to the 2, and we don't have any x variable in the last term. So actually x is not common. Yes, it's common between the first two terms, but it is not common among all of them. So how do I factor this? Actually, this expression, this polynomial, is not factorable. Cannot be factored. Cannot be factored. Okay, so not every polynomial is factorable. Some of them is not factorable. Example number 2, it's a skill, it's a word problem based on the first example. The area of a court for the game squash is 9x squared. 9x squared plus 6x square meters. Guys, everybody knows the squash yard is a rectangular shape, length and width. So the area of rectangle is equal to length times width. We called length and width the two dimensions of the court, of the squash court. What do we need? Factor this polynomial, the area, the polynomial of the area. Factor this polynomial to find the possible expressions for the dimensions. We need the possible dimensions, length and width. They are multiplied together in this form, in the polynomial form, and we need to write this in the factored form. Okay, guys? So how do we do this? By factoring out the GCF if possible. What is the GCF of 9 and 6? It's 3. What is the GCF of x squared and x? It's x, the variable with the least power. Because we started with a binomial, so we need parentheses. We need a binomial factor. How do we get the other factor? by division, or you ask yourself 9x squared is 3x times what? Yes, times 3x. And you copy the plus sign. 6x is 3x times what? Times 2. You can always check your answer by doing distributive property mentally. 3x times 3x, 9x squared, 3x times 2, 6x. So guys, one of these dimensions is length, the other one is width. So possible expressions for the dimensions of the squash court are, one dimension is 3x and the other dimension is a binomial. It's 3x plus 2. Which one is length, which one is width? I don't care. Any one of them can be the length, any one of them can be the width. Thank you guys. See you in the second part of this section.